Ladies and gentlemen, we would like to welcome you to the fourth webinar within the MAPLAN Virtual Days. My name is Bernd Schritteser. I'm managing partner of the company Scioflex, and as an engineering office, we assist you in the field of polymer engineering and elastomer technology. Today, I welcome Ben Buffer together with me for the session, and I'd like to ask him to introduce himself.
Good morning, Bernd. How are you?
Thanks, great. Also, everything fine?
Excellent. Well, my name is Ben Puffer. I'm a regional, actually technical sales director with MAPLAN USA. So I am sitting in Michigan in the States. I've been with the company around 5 years. And, prior to joining MAPLAN, I worked in the field of HR as a HR business partner and consulted with managers on multiple different levels associated to learning and development, profitability of their locations, et cetera, et cetera. But yeah, please continue.
Thank you very much, Ben, for the short introduction. Today's topic is about CAPEX and OPEX. So it means investment costs versus operating costs. And what is the reason why you came up with this topic?
That's a great question, Bernd. Actually, I prepared a presentation to start talking through some of those things. So if we want to get into that, we can do so.
Perfect. And please start with the...
Before we review the outline for the webinar, let's discuss why this topic came to be part of MAPLAN's Virtual Days of Technology. The Association for Rubber Products Manufacturers, otherwise known as ARPM, is a USA-based member-owned organization that publishes an annual State of the Industry report for the entire US rubber industry. In the latest 2020 report, the top challenge cited by 84% of the survey respondents was workforce development, otherwise known as attracting, retaining, and developing employees. And this is a trend expected to continue in the entire manufacturing sector well into 2030. And this is based on a study released in May 2021. It was a conglomeration by Deloitte and the Manufacturing Institute. Basically, the Manufacturing Institute is like the workforce development and education partner of the USA-based National Association of Manufacturers. The manufacturing sector is experiencing a huge talent shortage as an unprecedented number of experienced and knowledgeable veterans are retiring, baby boomers, leaving hundreds of thousands of jobs to be filled by those with less experience and less knowledge. So without these veterans in the rubber industry, molding equipment decisions may be solely based on initial investment requirements provided by corporate accounting groups or finance departments without any consideration for the long-term impacts on operational expenses. So this talent shortage forces rubber molders to either attract and develop their own internal talent or apply more pressure to suppliers like MAPLAN to offer increased support during the purchasing experience. To gain more insight into our customers' experience, we actually sat down and recently interviewed 2 of our longtime USA customers to ask about their experience with the talent shortage and how they approach acquisition of molding equipment. So let's take a look at those.
So it's a great challenge in our business is identifying and maintaining talent, especially on the processing side. I think it's, we never feel like we have enough or have enough depth. We have a few go-to folks on our team that we constantly try to pair up with others so that they can learn and understand their problem-solving techniques, just the nomenclature of the equipment and the rubber. We're constantly playing that game. So for us, we invest in internal training, and we have a multitude of different, avenues, hands-on, classroom, the kind of like a rubber 101, if you would call that, to get understanding the rubber itself and we play with almost 15 different base rubbers. And so trying to get them understanding that. So when they do touch a machine and or a molding process, they know the same tricks that they used on the other one might not work on this one, or something that you did on transfer isn't going to work on an injection machine, because the mechanics of the equipment is fundamentally different. So ultimately, identifying that talent early is key. Not letting them get too far down the road and getting bad habits, I think, is something else that we've learned. So the earlier we can identify somebody that's motivated to learn, motivated to grow with the organization and into a technical role and a leadership role on the floor, because ultimately our process development team is they're constantly training. They're constantly training our operator team, and they are playing into both sides of the spectrum. They help with tool reviews, and they help with just the day-to-day troubleshooting on the production floor.
So it is harder, and so deliverability, how fast can that supplier give us the piece of equipment once we make the commitment we want it, in this day and age becomes quite an important factor there. The other one that plays back to your first question about engineering and process engineering is familiarity with equipment. And again, I think this actually applies to large companies and small companies alike. If one is going to keep bringing in different pieces of equipment, or if you like, different brands of equipment, that becomes very burdensome in terms of an expertise that one can glean and bring into play. And so consistency is important for the ability to operate it, both for the engineering side and for the press operators themselves. If they can consistently operate a press in the same manner, they know which buttons to push and how to adjust the things we do permit them to adjust. That's a darn sight easier than every press operating in quite a different way. And so that's an important factor. It's got to be justified by the quality, how well it stays up and running for us, which comes back to our OEE we'll talk about. So it has to do the job, of course. That's just a given, unfortunately. But some presses and some brands don't work as well as others. They break down more. And the last bit of that consistency is the ability to maintain adequate amount of spare parts, and or to cannibalize an existing piece of equipment in an emergency to keep a more important piece of equipment running. And again, if one has single brand or predominantly one brand, that's a lot easier to do. We have less parts on the shelf. We're able to chop and change more readily. Not always the case, because as one goes through newer and newer equipment, there are changes that sometimes are not retroactively fitting into each other, but it's certainly more likely that we can get away with a lot of that if we consistently go with a brand X rather than mixing and matching. The other way we use OEE is more on as a measurable of our ongoing performance, of course. And with those three segments of the OEE, the machine uptime, how many hours a day is it actually available to us, the run rate versus our expectation, and then the overall quality, what percentage of the parts we're making end up being good. And we look at those three facets. Different departments or employees or groups of employees are probably, there's crossover, but they're probably responsible for those different facets. So the machine uptime is more a relationship both of our supplier, of the equipment and how well they can support us and the reliability of their equipment, coupled with our own mechanical abilities and our maintenance team on keeping them going, everything from preventive maintenance to how effective we are on our scheduling front, how rapidly and effectively we can change tooling, clean tooling when it's an ongoing part that will stay in for a lengthy period of time. Those are things that between our maintenance / technicians and the suppliers, technical capabilities / the consistency of their equipment, they are responsible, if you like, most predominantly anyway, for that machine uptime. The run rate versus expected run rate is really down to the production team, the operatives themselves and their supervision. How many cycles against an expected number of cycles are they achieving? Some of that is controlled by the equipment, but not all of it. So how well are they doing? And that covers everything from being timely on breaks and start and end of shift, to the nature of the handovers, to how quickly one demolds and gets the press closed up. I've always somewhat flippantly told all operators that no press makes us any money unless it's closed. So don't leave it open, get it demolded, closed up again, and then we'll worry about everything. So they control predominantly, not exclusively again, but predominantly the run rate facet of the OEE. And then the third one is the quality. Everyone can impact that, from the capabilities of the equipment, its breakdown, the heating elements through to operators perhaps not doing quite as good a job as they should. But predominantly, we say quality is down to, if you like, the process techs and the chemist. Are they putting the tooling in? Are we designing the tooling to be effective? Are the materials good from both our supplier and our own chemical capabilities? So those three facets of OEE, the machine uptime, rate, and quality, when multiplied together, give us our overall equipment effectiveness. But we have different groups within the company, internally and externally, who have the largest impact on each of those facets.
We really appreciate those USA-based customers offering their insight into the talent shortage and how they purchase or look at purchasing rubber injection molding equipment. So thank you to both of you. So today we're going to focus on 5 key questions to try and share an optimal framework for planning and evaluating molding equipment purchases through an investment and an operational lens. And these 5 key questions are: what is our situation? What molding process fits best? What are the critical factors? How can we evaluate our critical factors? And then how does it work in reality? We recommend the first step before any major capital purchase is holding an internal meeting with key team members in order to better understand your organizational situation. This will ensure that everyone involved has the proper picture of your situation and will be able to filter the ideas and solutions and capabilities, features and benefits, all of the stuff offered by suppliers during the process through a very clear organizational lens, instead of becoming distracted with fads and gimmicks and maybe non-value added features. So we've organized these topics into 4 elements: organization, resources, project, and parts. When discussing organization, we want to look at your high-level business situation, including your company culture and your capabilities, your existing equipment, and your potential for change. What is your company culture? What specific preferences does your team have about how things are done? What is your team strongest at? What is your team weakest at? What talents does each team member contribute? What equipment do you have now? What's its condition? How comfortable is your team with this equipment? And what does your team like about it? And what do they not like about it? Probably the biggest component is how comfortable is your team with changing equipment, with updating equipment from the same supplier, or maybe introducing a whole new supplier. So when looking at resources, we want to consider the people, the materials, the energy, and the physical space available. What type of talent is available to us, and what's the cost of that talent? What is our raw material cost to make our parts? And what's the cost of waste? What's the cost of electricity, water, compressed air? How much available space do we have in production? Can we expand? Are we space limited? These are all the pieces that we want to take a look at under resources. When discussing a project, that's when we need to consider what's needed to create a project that's successful. What are our expectations of this project? Is it new business for our team? Are we adding capacity to an existing production process? Are we replacing aging equipment? How do we define a successfully completed project? What talent resources do we currently possess to manage this project? And what's our deadline? What milestones need to be put in place in order to ensure that it's successful? And then finally, the parts involved should also be considered. what is our current annual production volume requirement? Will this requirement remain static? Is it going to grow? What is the ultimate part performance requirement from the customer? What's the geometry of the part? If appropriate, what inserts will be in the part and what material are the inserts? What are the best processing conditions for the compound used to make the part? What is the current production process and what are its successes and limitations? After we gain a clear understanding of our entire situation, then we need to determine the optimal molding process for the project. As Stephen Covey wrote in 7 Habits of Highly Effective People, we should begin with the end in mind and define the molding process best suited to our situation and our project before engaging in the evaluation of equipment. Many rubber molders have capable process engineers on board and can work through this type of decision internally. However, not all rubber molders are blessed to have that type of internal process talent. And there are so many process choices. Do we use compression molding or transfer molding or injection molding? Do we use a hybrid like injection transfer or injection compression? Do we use a horizontal machine or maybe a vertical machine? Do we use a 4-post machine? There's also C-frames, tie-barless machines. Do we invest in an ergonomic machine so that our operators have an easier time? Or do we spend less and get a traditional machine? Do we use a hot runner? Do we use a cold runner? If we use a cold runner, do we use open nozzles? Do we use valve gate nozzles? Do we use a solid block or a split block? I mean, that's just cold runners. And then do we use traditional manual operations, or maybe we move it a little forward and we use semi-automated solutions like plate handling? Or do we pursue a completely automated option? The optimal process is discoverable through research and development by a capable process engineer, but you can also ask a trusted supplier like MAPLAN for help if you don't have the talent available for the project. Now, once we have the properly defined and the optimal molding process, and we know that's what we want to pursue, then we need to sit down and define all of the critical factors that could impact your CAPEX and your OPEX in purchasing rubber molding equipment. When defining our critical factors, CAPEX and OPEX are like 2 halves of the whole decision. Anytime you have CAPEX associated to building a rubber molding process, this nearly always requires additional investment into other ecosystem components. That's above and beyond the molding machine. So these additions could include tools or molds that are used in the machine, maybe jigs and fixtures used to equip the molds, so maybe a jib crane or something like that. Automation components, if you mix your own compound, the mixing equipment for that. There could be secondary operations equipment like trimming and slitting, maybe cryogenic deflashing equipment. You also have quality control equipment like measuring tools, lab devices, vision inspection. And then you have facility utilities as well. So chillers, air compressors, exhaust systems. CAPEX is very distinct from OPEX. And typically it's incurred one time. It's incurred at an organizational level. And because of that, it's very highly visible to the organization. Now, the advantage with CAPEX is that it can be depreciated every year for 3 to 7 years, and then reduced every year. So while CAPEX costs are an important thing to consider, they are very visible, it's not the whole picture. It's only the first half of the picture. So in looking at the second half of the picture, that's where OPEX comes into play. And we've broken this down into 5 different components. So we have performance, material waste, consumption, labor, and maintenance. The performance capabilities of the molding production process can impact cycle time, unplanned downtime, production planning, and part quality. A process capable of minimizing cure and maximizing cycle speed will obviously increase your part production per hour. A reliable process will minimize lost production time associated to unplanned downtime. And a consistent process will aid in planning production schedules. And then finally, a repeatable process offers more consistent part quality with fewer defect claims. The second thing is material waste, and that's often attributed to part rejections or scrap rate, but it's also important to consider the compound waste due to your startup and shutdown sequence. If you do compound changes, what's the cost of the compound between those? Any unnecessary compound purging between cycles. And then additionally, insert waste, maybe due to part rejections caused by non-repeatable process. Those should also be considered. Our third element is an ongoing cost associated to the energy consumption. So that could be electricity, it could be water for cooling, maybe compressed air. You could even consider the hydraulic fluid and filters with the machines. These factors may not show significant differences if evaluated over a single cycle, but they add up to pretty large savings when calculated over maybe the 15 to 30 year lifespan of your equipment. Another consideration is the consumption of the physical space compared to the part volume produced. Facilities have both actual and opportunity costs, so a more compact molding production process offers higher space efficiency. Now, your process setup labor, your operator labor, your secondary operations labor, and even your maintenance labor are all also part of your OPEX concerns. If the molding production process offers minimized or maybe even eliminated labor in any of those areas, OPEX can pretty greatly be reduced over the life of that equipment. Finally, ongoing maintenance of the system is always necessary in any production process. The required frequency and duration of that scheduled downtime, the costs, availability of parts, maybe the cost of labor from the supplier technicians, those are all going to impact OPEX as well. Another non-financial aspect to maintenance is maybe the technical support offered by the equipment supplier. Are they capable? Are they dependable and available? Are they helpful and supportive when available? Mediocre supplier support impacts the duration and the reoccurrence of planned and unplanned downtime. So, unlike CAPEX, OPEX costs are incurred every day. They are incurred typically at the plant level, and they're way less visible. We've even seen some circumstances where they may be hidden from management. They're not depreciable, and they will continue to increase over the lifetime of the equipment. One recommended method of evaluating OPEX could be using something called OEE, or Overall Equipment Effectiveness. And this evaluates 5 different levels of production losses through schedule, availability, performance, and quality losses. So if you want a little more information on that, take a look at a website, oee.com, if you want more information. So while CAPEX costs are often considered when quoting new projects and then determining the business case of equipment, really OPEX will ultimately have a larger impact on the actual production costs. Now that we've reviewed our organizational situation, we've determined the optimal molding process, and we've broken down the different components of CAPEX and OPEX, we can now launch into a standardized framework for evaluating these investment decisions. So this framework was formed through pretty extensive experience working and collaborating with our customers. And it's worth noting that this standardized framework is really supposed to be a starting point. It's like a best practices list. And really, you should be amending that to reflect your unique situation and your project within your organization. So we're going to speed through these fairly quickly here, and hopefully the prior discussion gave some context, but let's look at CAPEX first. So when evaluating CAPEX and looking at this framework, we can really break it down into 3 different sections. So the first is machinery investment, then ergonomics, then production flexibility. So within machinery investment, we should be considered the typical things that people look at: the pricing, the lead time, and the expected longevity of the equipment. How long is it going to last? Within ergonomics, we should then consider the operator experience. What's the working height? What's the strip or stuffer height? What is the simplicity of the controls? Maybe what is the operator's exposure to heat and fumes? All of those other ergonomic aspects, along with the machine footprint. That's another important piece. Then when we look at production flexibility, we should be considering the range of capabilities that that machinery has to handle different compound types, different volumes, and different pressures. And then finally, you probably also want to consider the semi and fully automated production capabilities available and how the equipment connects with all of those other ecosystem components. So CAPEX really kind of summarizes all of the equipment-related decisions. Now, when we look at OPEX, we can break this down into 4 different sections. We have process waste, future readiness, maintenance, and service. Process waste should consider the labor, the energy, the water, air usage, scrap rate, compound waste, compound changeover costs and time, and even mold changeover costs and time. It's all of those wastes associated to the process. Future readiness, that's where you want to evaluate things like the equipment's ability to add automation options later, maybe remotely access the machine for service and support, conform to new Industry 4.0 features like machine learning or machine communication. Then when we look at maintenance, we should be evaluating warranty length and coverage, spare parts cost, what's the required frequency and duration of maintenance, and then ultimately, what is the unplanned downtime of that machinery. Service should then consider the responsiveness to the requests when there is downtime. And that could be the initial response and the physical response if needed. So, initial response could be the phone call or remote access, and then the physical response would be on site. Then you also want to look at the capability of the remote service. How much support is there within that? And then the availability of regularly needed parts. So that's the framework. And by using that framework, after taking the time to understand your situation and then determine that optimal process, hopefully you'll be better able to truly evaluate the complete picture, the OPEX and the CAPEX and the OPEX picture when the time comes to invest in molding equipment. So we've gone through a lot of different pieces. We've talked about a lot of different things. This framework's good in theory, but let's look at a specific MAPLAN customer example to see how it could be applied. So our customer case study here is a company called Belay out of Germany. And the image that you see on your screen is Lutz Leisebein, who is the CEO of the company. Belay is a smaller rubber molder. They have around 25 employees and 9 injection molding machines. And they recently went through the process of replacing an older Pentaject vertical injection molding machine. And it's important to note that Pentaject is a previous MAPLAN brand, probably around circa 1980s. And the evaluation that they went through compared both the CAPEX and the OPEX components in order to determine the overall ROI of that machine investment. And so what's interesting about this is that we compared that older Pentaject machine with a new Ergo Plus machine from MAPLAN's lineup. And the comparison of the figures you see on your screen here sort of summarize what we found during the OPEX component of that evaluation. So you see here machine availability on the Pentaject was about 80%. The inverse of that would be downtime, both scheduled and unscheduled. So roughly 20% downtime. And the Ergo Plus, we have a machine availability around 95%, so about 5% planned or unplanned downtime. In addition to that, the number of parts produced per hour was much greater on the Ergo Plus than it was on the Pentaject. And part of that, I'm going to skip down to the bottom here, is that the Pentaject required an operator. Whereas the Ergo Plus, we were able to go fully automatic with this solution, and that makes better throughput. I mean, there's more technology involved than just the automation, but that's one probably larger influencing factor. Now, the consumption was also interesting. We looked at this both on a per cycle basis and a per part basis. So you'll notice that the electrical consumption from the Pentaject was about 0.46 kilowatt hours per cycle. And on the Ergo Plus, we're about half that. In addition to that, the per part electrical consumption was 114 watt hours versus 61.3 watt hours. So we're even able to break it down all the way to the part. Now, this data comparison is interesting, but if we look at the summary, we see some pretty staggering comparison. We were able to reduce the energy consumption per part by about 40%, while increasing the productivity 41.2%. So when you compare the OPEX components, we can see that there was large savings on the energy consumption and the throughput was increased in addition to that while reducing the energy consumption. So this is one particular case study. It's certainly not indicative of all customer circumstances, but it's a really interesting case study of a company who was able to look at both the CAPEX investment and the OPEX components to determine what the best solution was for them. Now, one of the things that we wanted to do when we set out to create this webinar is to go through these different components and offer a sustainable project planning methodology, but we also wanted to give a resource so that you as our viewer would be able to approach it in a similar manner. So what we did is we created an evaluation spreadsheet. And this spreadsheet has both components, CAPEX and OPEX, and it breaks down a forced ranking system to be able to compare multiple suppliers. So what you see here is that evaluation. And what you would do is you would take each of these components in the different CAPEX categories, the elements that we broke down before. So for instance, machinery investment, we have a max percentage of 33%, but we use pricing, lead time, and expected longevity as the subcomponents that build the score. And what we do is we compare these three different suppliers and we say this one would be, the top supplier, it gets 3 points. This one would be the next top and that would be 2 points. And then the one on the end, the worst, would be ranked as 1 point. And then the spreadsheet will end up force ranking all of those and then adding it all together for you. So you get a percentage. So machinery investment out of 33% max in that category, we can see that supplier A honestly has the worst pricing and lead time out of the three, but expected longevity is very good. Whereas supplier B may have really good pricing and really good lead time, but the expected longevity is not that great. And then supplier C seems to be a jack of all trades, decent pricing, decent lead time, and decent expected longevity. So of the three, it seems that supplier B was the best at 26% out of 33% max compared to the other two. But then when we start to go down further into like ergonomics and production flexibility, we see a little bit of a change there. We see, a higher ranked supplier A and a tied supplier A and C for production flexibility. And then when you take everything into consideration under CAPEX, we find that supplier A actually ties supplier C, but supplier B, who actually had the best machinery investment and on a surface level looks to be the best, actually ranks the worst when you look at all of those other components. Now, again, that's the CAPEX side. If we go to the OPEX side, we can see process waste, future readiness, maintenance, and service and support all in a similar manner. Now, since there's 4 mechanisms instead of 3, these have a 25% max score. And we go through the same process. So we rank all 3 suppliers. We assign a 3 for the best, 2 for the one in the middle, and 1 for the least. And then the system adds up all of these different components. So our OPEX subtotal, we see that supplier A actually has the best on the OPEX side, followed very closely by supplier C. And then supplier B, a solid 51%. I mean, not great. And then we average all of those between the CAPEX and the OPEX, and we get our grand total of that group. Now, again, I want to restate that this is a framework that offers a good starting point. It's not an end-all be-all. It's not going to be perfect for all circumstances. And so us sharing this spreadsheet and us sharing this resource is really meant to be the beginning for you. And when you go through your initial company meeting and you go through all of those different components to figure out your situation, you determine your best process, and then you walk through this type of a spreadsheet. Ultimately, you may add things. You may change what the force ranking percentages are. You may add another supplier. You may remove another supplier. But the spreadsheet is there as a resource to give you this specific framework and then allow you to adapt it to what meets your needs the best. So we've talked a lot about the CAPEX and OPEX sides of a purchase decision. And ultimately, you might kind of be thinking, how does MAPLAN compare? And what a good looking question. So MAPLAN really kind of carries an understanding of what your CAPEX requirements are, but we have really a focus on our OPEX. And so there are many different technologies that we could talk about. We'll save some time today, and we're only going to hit on a couple. But the example here we have is a MAP auto cell. And in this MAP auto cell, this is a 360-degree turnkey solution. This would be the type of solution that might be appropriate if you don't have that internal process talent. But we have a couple different technologies on here to talk about. First is MAP FIFO Original. So this is our original injection unit. This includes something called all-out technology that allows you to minimize your compound waste between compound changeovers and maybe mold changeovers. We also carry a different injection unit called our MAP FIFO Ergo. And this injection unit has a lower strip excess so that your operators can reach up and feed the rubber in. This auto cell also includes something called MAP Cool Drive, which is our consumption-saving servo hydraulic system. In another video during Days of Technology, we talked about our cold runner blocks, our MAP CRB series, so I invite you to check that out. But all of our cold runner blocks are designed to minimize your compound waste. We also carry MAP Auto Cell, like you see here, where we have fully automated and integrated solutions. We also have semi-automated solutions if fully automated isn't your thing. And then on the service and support side, we also have MAP Remote and MAP Web, which are options for us at MAPLAN to remotely support you and also for you to remotely support yourself. Those give remote access and support to machines and production cells. And then we also carry MAP First Aid, MAP Care, and MAP Care Plus, which are our spare parts packages. And you can kind of stock the appropriate amount of parts based on your risk tolerance. We can talk about these all day, but really, we just want to invite you to reach out to us if you have any questions or if you want more information on this, and then we will connect you with your appropriate sales team.
Thank you very much, Ben, for this nice contribution. I'm convinced that really a lot of people are interested in this CAPEX and OPEX topic, also when you think of sustainability. Also, during the presentation, we've received some questions, and I would ask the Rishi for the questions. Thank you very much. And here we go. So the first one, Ben. We mentioned, or you mentioned in the presentation, that MAPLAN holds an understanding of CAPEX requirements, but has a focus on OPEX. How does MAPLAN focus on OPEX?
Yeah, that's a great question, Bernd. So obviously, we talked about some of the technologies that MAPLAN offers that are a little more focused on CAPEX or on OPEX. One of the things that we do offer above and beyond just the technology is a fairly robust sales team. And so one of the things that I would suggest, as I said before, reach out to your sales team. We can go through some of the technologies with you. I mean, one of the perks of having a sales team is we can take each of those elements and we can break them down in your exact situation. Along that same line, we as a team have developed a couple different resources that we use on the sales side. So the first one that I'll bring up is actually a consumption analysis. And this particular document we've used on multiple projects. The particular example you see here, we used specifically for that customer case study with Belay. And this particular tab shows that the overall actual energy consumption of the Peneject machine. And we can see the energy usage due to the machine itself. We can see the energy usage due to the heating plates. We can see the water consumption. I mean, we can break all of those different consumption pieces down into a final assessment. And if we go to the second tab here, we can also see a comparison to the Ergo Plus machine. And when we look at both of those side by side, that's part of what helped us understand what the difference in energy consumption could be, and helped with the analysis for the customer. So this is one specific example. It's an energy consumption study. A second spreadsheet that we use is an ROI calculator. And when we compare the force ranking spreadsheet that we shared earlier, so that force ranking spreadsheet was really designed to be an aid in the decision making. And it probably gives CAPEX more weight than it really deserves. But I mean, what rubber molder out there doesn't look at CAPEX as a barrier to entry, right? I mean, you always look at the cost of the equipment on the front side in your evaluation and your decision. Well, this other spreadsheet helps to break down all the different elements associated to both CAPEX and OPEX, and then calculate an ROI. So the part of the reason of sharing those two things with you is we use those on a case-by-case basis. I would invite listeners out there, if you want to really evaluate your specific circumstance, touch base with your sales team, and we can go through those tools with you and help you understand how that would apply to your circumstance.
Thanks very much for this answer. And this brings us also directly to the second question. What seemed the best return on investment option for developing process engineers from existing employees?
What a good question. So I'm going to address the first part of that. We can all kind of acknowledge that attracting and hiring external talent is pretty costly. It's expensive to find that. You have to invest the time in it, or maybe hire a headhunter, and there's risk associated with that. And so hiring someone from outside the organization can be a little bit unnerving. So that's a great question of how do I take my lower risk if I have people on staff that I can invest in and minimize that risk and that expense. And so one of the things that I would recommend, just from experience with customers, is you need to identify that type of person very quickly. Because when that person comes on staff and you see the potential in them, you see the ability for them to invest themselves into becoming a process engineer, you need to capture that energy and capture that effort to move them forward, but also catch it early enough that you can prevent bad habits from forming. Now, if you're going to go ahead and develop that talent internally, we have classroom options. I mean, MAPLAN even offers training for process. We are more than happy to do that. Again, reach out to after sales if you have questions on that. The thing with rubber, though, is aside from the supplier training, there really isn't a lot of academic classroom situations available where it offers some type of an on-hand, like hands-on, that's the word I'm going for, a hands-on approach where you can actually invest that person into working machinery. So the only probably best ROI that's left is mentorship. And the best practice that I've seen is to take that high-performing person that you've identified and pair them with a mentor who is knowledgeable, a veteran in your company, but it needs to be the right person. It needs to be the person who's patient with that person to develop them and encourage them and stick with them. Because otherwise, you could be left with a person who mentors a little bit and then leaves that person alone. And that tends to cause mistakes. It tends to cause problems. That person is empowered but has no oversight. So I would say the best ROI so far in the rubber industry is to identify the talent early, capture that, and then pair them with a veteran who can give them patience, oversight, and the proper training to develop them into that process engineer that you want.
Thank you very much for this. You mentioned the proper training and also classrooms, what would be available via MAPLAN. Can you go a little bit more into detail? Is this training only focusing on the processing, or is it training also focusing on material side, for example?
Yeah, that's a great question. We do a lot of that. So we have the process side training. We can also do specifically like new customer training if they want some enhanced training based on learning the control system or the features of the machine. We've even done remote training. So it really is more in line with what your specific needs are as a customer. If you communicate those to us, we do our best to meet that and then offer you a couple different options for how to deliver that, whether it's remote or on site or in classroom. We really are pretty flexible when it comes to offering training on MAPLAN machines and on process.
Thank you very much for this. And now the last question, a very good one. What differences do you see in how the USA approaches CAPEX and OPEX compared to European countries?
That's a good question too. There are quite a few differences, I would say. I don't have a significant amount of experience with the European market, but I think enough to maybe make an assessment here. The first thing that comes to mind for me, back when I was doing my bachelor's degree, we had a business analysis called a pest analysis or environmental scanning. And they call it PEST because it's an acronym. It stands for, it's a system of looking at the environment around your business and determining how that environment is going to impact your competitiveness. And it looks at your political environment, your economic environment, your societal environment, and your technological environment. And I think the two biggest pieces between the US market and the European market probably fall into the political environment and the technological environment. In Europe, my assessment is that there are a lot of motivators for rubber molders to invest in green technology. And I think in addition to that, the cost of power and the limitation of space, like there's a lot of pieces that contribute to Europe being more green friendly. And so when it comes to looking at those OPEX components and the energy consumption and the water consumption, space consumption, I think that Europe really leads over the US because electricity is relatively cheap compared to Europe, water is relatively cheap, and space is relatively cheap. So US molders haven't really been in a circumstance where they have to evaluate that compared to Europe, where I think in order to be competitive, you have to look at those things. It's necessity. And then on the technological side, Europe has always been a bit more advanced on the automation and looking at all of the ways that you can minimize operator involvement. US, frankly, Americans are stubborn. We like doing things the way that we've always done things. We are starting to see a change in these two trends, though. So with automation on the supplier side, we've seen more and more pressure from US manufacturers to look at how to automate processes and to look at the overall machinery ROI. And on the political side, we've also seen, actually just this week, President Biden signed into law the Infrastructure Act. And so I think the situation for US molders is starting to change. We lag behind Europe a little bit, but I think that political and technological piece, I think that's really where we see a marked difference.
Thank you very much, Ben, for this detailed insight. I think there is nothing more to add. Finally, it was a pleasure for me. We would like to thank you for your contribution and for the talk. Also, thank you very much to the audience for the questions and the interactions. If there came up any other questions, maybe later on, please just contact us. We try to answer everything. And I think this topic around CAPEX and OPEX was a great conclusion of the MAPLAN Virtual Days. I'm looking forward to the next series in March 2022. You will be informed over the usual channels. Until then, I wish you a wonderful time and see you soon. Goodbye.